So we can write down the omega is equals to like mg L divided by I. Okay, if I omit the lower portion from the board, then I can this is the moment of inertia. Like we can calculate the moment of inertia I from the equation is looks like I is equals to what? Our pendulum is that, and this is the pivot point, and this is the center of mass, and the length is called what? L. So the if the mass of this pendulum is m, then the moment of inertia is called be ml square, and m k square because the radius of gyration of this pendulum is k, and so the total moment of inertia will be looks like ml square plus mk square. If we yes,
I didn't understand why we wrote I equal to ml square plus mk square, sir.
this is the moment of inertia. What is the definition of moment of inertia? Like mass into the length square, or তোমাদের যেই আমার এক্সিসটা আছে, এক্সিসটা থেকে ওই পোরশনটার যে ডিসটেন্স তার স্কয়ারকেই আমরা কি বলবো? মোমেন্ট অফ ইনার্শিয়ার ডেফিনিশন কি ছিল? এরকম ছিল না? I is equals to m into r square.
Yes, sir.
Yes, sir.
It's
Okay.
for radius of gyration, sir.
Yes, so we
Sir.
use yes.
Sir, what do you mean by K?
Here k is the radius of gyration. The Bangla meaning of this like what?
চক্রবর্তীর ব্যাসার্ধ।
Yes,
চক্রবর্তীর
yes,
ব্যাসার্ধ,
this is
চক্রবর্তী।
চক্রবর্তীর ব্যাসার্ধ. Okay, by using this we can calculate this. The moment of inertia calculation is not important for our purpose because we need to show that our compound pendulum is in the motion of simple harmonic motion, and the frequency is like mgl by I, where I is ml square plus mk square. If we put the value of I here, then the equation will be looks like m into L square plus k square. We can omit m from both the numerator and denominator, right? So we also calculate the time period from this equation. We know that time period t is equals to what? Twice pi by omega. So we can write down this equation like twice pi root over L square plus k square divided by gl, right?
Sir, could you please show K in the figure, sir?
Yes, I will show again the figure. This figure is already
Sir,
drawn on the
Sir,
board.
L is present, but there is no K in the figure, sir. We didn't
Okay.
understand the identity of K.
Okay, the k is the radius of gyration. The radius of gyration means পিভট পয়েন্ট থেকে আমাদের এই যে যে পেন্ডুলামটা আছে, পেন্ডুলামটাকে একটা পয়েন্টের উপরে, লাইক আমরা যে কোনো জিনিসের রেডিয়াস অফ গাইরেশন বলতে কি বোঝায়? লাইক দিস ইজ কোয়ান্টিটি অফ মাস। ওকে, আমরা এখানে একটা পয়েন্ট আছে, যেই পয়েন্ট থেকে তার ওয়েটটা কি করে একদম নিচের দিকে ইয়ে করে, ডিরেক্ট করে, সেই পয়েন্টটাকে আমরা বলবো আমাদের এক্সিসটা থেকে সেই পয়েন্টের ডিসটেন্সটাকে কি বলবো? রেডিয়াস অফ গাইরেশন। ওকে, ইয়েস।
আমরা যখন I equal to mk স্কয়ার নিচ্ছি স্যার, তো যেহেতু k রেডিয়াস অফ গাইরেশন, তাহলে স্যার L স্কয়ার নেওয়ার প্রয়োজনীয়তা কি স্যার?
ওকে ওকে, এম এল স্কয়ার দেখো রেডিয়াস আমরা তোমরা একটা ইয়ের কথা জানা আছে কিনা? ইউ হ্যাভ টু ফর্মুলা লাইক দ্যাট, the total moment of inertia is equal I is equals to what? Ix plus Iy, parallel axis relation of the radius of gyration. So you need to add both the part of your radius of gyration. That means Ix plus Iy. Okay, these are some complicated steps, so recommend if you want to understand the whole part, you will connect me personally. You can email me. I will answer all those questions about this stuff. This is not really focusing point of this course. Okay.
Yes, sir.
Okay. Okay. If you really wanted to know about these things, so you can ask me question by sending an email. I will answer all this question there, because if I go to these topics, then I cannot move forward in my class.
Okay, this is our time period. Time period t is equals to what? Twice pi by omega, and if we put the value of omega in the here, we can find out the value of our time period in case of our compound pendulum. This is the time period of our compound pendulum. Okay.
Yes, sir.
Okay. Then we will move forward. Now here is an interesting part that.
লাস্টেরটা কি লিখছেন স্যার একটু বুঝে আসছেন স্যার টি ইকুয়াল টু
t is equals to twice pi by omega, and if we put the value of omega, we can calculate that twice pi root over L square plus K square divided by ZL.
Yes, sir. Thank you, sir.
Okay. Then in the case of simple pendulum, if you think about a simple pendulum like this pendulum, okay. If you think about the simple pendulum only have this length like L. There is no other radius of gyration or any other things in case of simple pendulum. So in case of simple pendulum, the moment of inertia will be like half m L square. Okay. So our equation of omega is like what? Equation of omega is equals to like what? Root over m g L divided by I. So in case of simple pendulum, if we put the value of I here, we will find that omega is like what? Root over m g L divided by m L squared. We can write down this equation by z by L, right?
Yes, sir.
So in case of simple pendulum, the time period t will be like t is equals to twice pi by omega. So we can write down twice pi root over what? L by G. Okay, this is for the simple case or simple pendulum.
ফার্স্ট I equal to m z square, sir.
M L square because the length is L. Okay.
তো আমাদের নেটের অবস্থা খারাপ তো স্যার এটা মানে
Okay. That's no problem. Then I'm going. Then there is. Then I need to show that the simple pendulum is also followed by the simple harmonic motion. I need to show it. Okay. Let's. This is a simple pendulum, and let's. We move the pendulum here. Let the length of this wire is L, and you move it by theta direction. So if the mass of this bob is mg, then the weight will be if the mass is m, the weight will be mg, and this is theta. That's why this portion will be mg cos of theta, and this portion will be mg sine of theta. Okay.
Yes, sir.
Okay, so from this we can write down this equation like আমরা এটাকে কোথায় এনেছি? এটাকে আমরা ফোর্স অ্যাপ্লাই করেছি কোন দিকে? লাইক এই দিকে না?
Yes, sir.
So our force F will be like minus mg sine theta. Okay. Again, you see that here the value of theta is really small.
Sir, why is the force negative?
Okay. You see in the figure that the direction of the applied force and mg sine theta is opposite. So here a minus sign will be needed. Okay.
Yes, sir.
Yes.
Okay. Then this theta is really smaller, so we can write down this equation like minus mg theta. Okay. So now I can omit this part from the board and write something here. Like I can write down this by we know that our linear acceleration a is equals to r into alpha where alpha is our what? Angular acceleration, right? This is the relation between linear and angular acceleration. In case of simple pendulum, we replace the radius by what? L. Okay, so we can write down a by d square x divided by dt square, and we can write down L alpha by d square theta divided by dt square, right?
Yes, sir.
So if we multiply m by both sides, so this is ma, so this is f, right? So we can write f is equals to ml d square theta over dt square, right?
Yes, sir.
Okay, then we can write down this equation like if we replace the value of m here, so we can write down this equation like m l d square theta divided by dt square, right? Okay, after this equation we can write down this by d square theta by dt squared plus g by l into theta is equals to 0, right?
Yes, sir.
Okay, after that I can let the value of omega square is equals to z by l. This is a constant, so we replace this by omega square. So again you see that the equation is looks like the equation of what? Simple harmonic motion. Now, if I go back to my slide, you will see that this is the equation of simple harmonic motion, and where omega square is equals to z by l, as we know that what? We know that t is equals to twice pi by omega, so we can write down t is equals to twice pi root over l by z, right? Okay, this is the case of for simple pendulum. Okay, now we will move forward. Our next topic is the LC circuit. What is an LC circuit? We need to understand, and then we will move forward because we need to check that our LC circuit is followed the simple harmonic motion or not. If followed, then we need to find all the other stuffs like time period, frequencies, and other things. So at first we need to know or need to understand what is LC circuit. An LC circuit is called a resonating circuit or tank circuit or tuned circuit. Consists of an inductor. This is the inductor L, and there is the capacitor C. Okay, we also know that the potential of the capacitor Vc is equals to Q by C. This is really familiar equation to your HSC syllabus, that the potential of capacitor is Q by C. Here Q is the stored charge and C is the capacitance of the capacitor. Okay?
Okay, sir.
Okay, then what is the voltage of the inductor? The inductor voltage is VL, and VL will be looks like L di by dt. In your HSC syllabus, the voltage is like E is equals to L di by dt or something like that. In Bangla, this is called আবেশ, স্বকীয় আবেশ গুণাঙ্ক, এরকম কিছু পড়েছিলে HSC syllabus-এ?
Yes, sir.
Yes, sir.
Okay. Oh, this is the things that voltage of this inductor is VL, and VL is looks like L di by dt, where I is the current flow and L is the inductor. As you then if I move forward my next slide, as you see here, there is no current source there. There is no potential source there. So in terms of Kirchhoff voltage law, we can write down this equation by the potential of inductor plus the potential of the capacitor is equals to 0, because there is no other source in this circuit, right? I think
Yes, sir.
you understand this, otherwise you can ask me question. বুঝতে পেরেছো সবাই?
স্যার আরেকবার বললে একটু ভালো হতো।
Yes, sir.
Okay, okay. I'll repeat my words again. This is actually the LC circuit. Here is an inductor and here is a capacitor. And the inductor voltage is like VL is equals to LDI by dt. We know that from our HSC level. And we also know that the voltage of a capacitor is VC is equals to Q by C, where Q is the charge of the capacitor and C is the capacitance of the capacitor. So if we as there is no other source in this circuit, so by using Kirchhoff voltage law, we write down this equation like the voltage of inductor plus the voltage of capacitor is equals to 0 because there is no other source in the circuit, right?
Yes, sir.
Okay. So after that, in the equation, you see that there is a di by dt. We know that the I is equals to what? dq by dt, right?
Yes, sir.
So if you put the value of I here, we will find the value L d square q divided by d square plus q by c. Then we will find this equation. And if we let the value of omega naught square is equals to LC, we can write down this equation like d square q by dt square. Here x means q, okay? And omega naught square into q is equals to 0, okay? So this is also like a simple harmonic motion, right?
Yes, sir.
Okay, where the frequency?
Sir.
Yes.
Sir, I didn't understand the last line, sir. That d square q plus dt square plus L by LC q is equal to 0. Like the second last line to the last line.
Okay. If you put the value of I in the first line, that the value of I is equals
Yes,
to
sir.
dq by dt, then you will find that this is a second order derivative of q with respect to t, and this is q by c. And
Sir,
if
this
you
is okay, but the next line, sir.
then if you divide this equation by L, then you will find this last line. I think this is easy to understand, okay?
Sir, is it 1 by LC or L by LC?
1 by LC. This is 1 by LC.
Oh, okay, sir. Sir, I understood.
Okay. So this is again the equation of what? The simple harmonic motion, where omega square is equal to what? 1 by LC. If I go back to my go forward to my slide, then if this is the equation of simple harmonic motion, the solution of this equation will be like q is equals to q naught cos omega t plus delta, right?
Yes, sir.
If we divide this equation by t, q by t will be I, q naught by t will be I naught, and sine omega naught t plus delta. If this is the cos term, if we interchange it, there will be a minus sign will appear in this fashion. Okay, this is really similar. And the angular frequency omega naught square is equals to LC. By using this, we can calculate the time period, because time period t is equals to what?
2 pi by omega.
Yes, time period
1 by
omega is equals to twice pi divided by t, right? So by using this formula, you can calculate t, and we also know that what f is equals to what?
1 by t.
1 by t. After finding the value of t, you can also calculate the frequency, and the frequency will be like 1 by twice pi root LC, right?
Sir, in the
Yes.
current in the circuit, we are differentiate ddt of q of t.
Yes, you can.
Then omega naught should be outside 1.
If
I
you
not omega
differentiate
not.
the value, yes, that's not I naught omega naught. That will be like theta q naught omega naught, right? Okay, the
Yes.
q naught I naught is also constant, and we can replace this constant by I naught. Okay.
Okay.
Sir, shouldn't it be IT is equal to minus I naught omega sine omega t plus phi?
Yes. Can you please repeat your question?
Sir, shouldn't omega not be outside the equation in the equation of IT?
Yes, if you differentiate this equation with respect to t, there will be a q naught I naught in the first position. Okay. Let q naught, q naught omega naught is q naught I naught is equals to omega naught. Okay. যদি তুমি এটাকে ডিফারেন্সিয়েট করো তাহলে কি থাকবে? সামনে একটা থাকবে কি q naught and আরেকটা কি থাকবে? Omega naught.
Omega.
Okay. Okay. Let this constant is I naught. Okay.
ও স্যার আমরা ধরে নিচ্ছি এটাকে I naught হিসেবে।
Yes. Exactly. Okay. Then if you have any other question, you can ask me. Otherwise, I will move forward. Okay. Then we will do a math problem here. As you see in the slide, there is a question for a simple harmonic oscillator where the value of k is given and the amplitude is also given. And as you see here, the position is like this equation. We know the equation of position. So the value of omega is equals to what? 8.08, right? And also there is a equation of v, and v is the equation of this fashion. Okay. Now we need to calculate. Our question number A is find out the total energy, right? Okay. So if we want to find out the total energy, we have the equation of total energy is equals to what? Half ka square, right? My previous class, I already derived the equation of total energy, and the equation of total energy is equals to what? Half ka square, right? সবাই কি বুঝতে পারছো, শুনতে পাচ্ছ আমার কথা?
Yes, sir. Yes, sir.
Okay. Okay. So if you put the value of k, because in the question you have the value of k, and also you have the value of a. If you put the value of k and a, you can find out the total energy from this equation, right? And the question number B is the kinetic and potential energy as a function of time. So our question number B is to what? To find out the kinetic and potential energy as a function of time, right?
Yes, sir.
Okay. So if we find out the potential energy, we know the equation of potential energy is equals to half k x square, and is the question, there is the value of k and the equation of x, right? If you put all the values here, you will find the value of potential energy from this equation, and the potential energy will be looks like this equation, right? বুঝতে পারছো? If you
Yes,
have
sir.
any question, you can ask me. Okay. Then what is your kinetic energy? Your kinetic energy is like total energy minus, you already calculate the potential energy. You already calculate the total energy, you already calculate the potential energy. So you can calculate the kinetic energy from this equation, and you can also calculate the kinetic energy by using the formula of mv squared. Okay, because you have the value of v is given in the equation. Okay. Okay. Is it okay?
Yes, sir.
Okay. Now, I think you have
you can ask me a question about how can you find the value of m, right? If I go back to the board, বোর্ডে দেখো, বোর্ডে দেখাই আমি এখন আবার, I think, okay. If you find out the kinetic energy, the equation of kinetic energy is like what? Half mv square. Okay, we have the value of v in the question, but we don't have the value of m, but we know that the omega
equal to
square
root
is equals to like k by m,
by m.
so we can put the, yes, so m is equals to k by omega squared, so we can put the value of half k by omega squared v square, like, right?
Yes, sir.
And we also have the value of omega because I already mentioned the value of omega is equals to what? 8.08 in the question. There is a mention in the question as you see in the slide that the value of omega is 8.08 because position equation is like x equals to a cos omega t. So the value of omega is 8.08. So after putting all this value in this equation, you can find out the value of kinetic energy. Okay, then our question number C is to find out the velocity when the mass is like 0.050 meter from the equilibrium position. So our next target is to find out the velocity. As you see in the slide, the equation of kinetic energy is total energy minus potential energy, and we know that the equation of kinetic energy is equals to half mv square, and we also know that the total energy is half k a square, and our potential energy is half k x square. From this equation, we can find out the value of v, and v will be looks like omega root over a square minus x square, and we have the value of a and we have the value of x in our question. Then we can find out the velocity of this equation. Okay, বুঝতে পেরেছো?
Yes, sir. Yes, sir.
Okay. Okay. If our question number D is to find out the kinetic and potential energy at half amplitude. Okay. So potential energy is equals to half k x square, and our half amplitude a by 2. If we do this calculation, we will find the value if I do this in the board, potential energy is equals to half k x square, and our half k and x is equals to a by 2. Then we can write down this equation like 1 by 4 into half k a square. And what is the half k square portion? This is our total energy E. So we can write down this equation like E by 4, and we have the value of E 9.80 into 10 to the power minus 2. So if you put this value, you will find the value of U. And you can also calculate the kinetic energy from this equation of like what? Kinetic energy is equals to what? Total energy. This equation is wrong. In the slide, this equation is wrong. If you find the kinetic energy will be total energy minus your potential energy, right? I think you understand that. If you have any question about this problem, you can ask me. বুঝতে পেরেছো সবাই?
Yes, sir.
Okay. Okay, then my last math problem of this slide or in this class is a 500-gram block on a spring is pulled a distance of 20 centimeter. Like একটা স্প্রিংকে তুমি 20 সেন্টিমিটার যদি পুল করে ছেড়ে দাও, 20 সেন্টিমিটার পুল করো, what does that mean? That means the amplitude is what? 20 centimeter. And the subsequent oscillation are measured to have a period of 0.8 seconds. What's the position? Is the speed of the block 1 meter per second. So there is T is given in the question. So we can also calculate the value of omega by using this formula. And we also know this formula like V is equals to omega root over a square x square. So if you can conclude this equation by x equals to what? Plus minus root over a square minus v by omega square. So you have the value of a 20 centimeter. You can put this. You have the value of v is equals to 1 meter per second, and you have the value of omega is here. So if you put all the values, you will find the value of x. Okay. I think you understand this. বুঝতে পেরেছো সবাই?
Sir.
Yes, sir.
Yes, sir.
Okay. Okay, then I will ask a question. Okay, roll number 06. তুমি কি আমাকে শুনতে পাচ্ছ? Roll number 06. Roll number 55. রিফাত হোসেন, তুমি কি আমাকে শুনতে পাচ্ছ? ওকে, রোল নাম্বার 55 এন্ড রোল নাম্বার 06 আমাকে শুনতে পাইনি। তোমাদের অ্যাটেন্ডেন্স দেওয়ার সময় কি তোমরা কথা বলবে না? 55 and 06. Okay. Roll number 64.
Yes, sir.
Okay.
So
Roll number
64.
Okay. Roll number 64. Can you please tell me what is the meaning of this plus minus?
Sir, স্যার এটা দিয়ে বুঝায় স্যার দুই দিকেই আমাদের পেন্ডুলামটার যে সরণটা হবে,
পেন্ডুলামটা না, আমাদের যে স্প্রিংটা ছিল, স্প্রিংটা তার ইকুইলিব্রিয়াম পজিশন থেকে স্কুইজ হতে পারে, এন্ড এটা কি হতে পারে আবার
নেগেটিভ দিকেও হতে পারে।
ওকে,
এক্সপ্যান্ডও করতে পারে স্যার,
এক্সপ্যান্ডও করতে পারে, স্কুইজও হতে পারে। ওকে 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 ওকে, দ্যাটস ইট। ওকে, নাও আই এম গোইং ব্যাক go back to MCAM for giving your attendance there.
হ্যালো,
Yes, who is there? Okay, I think now you can see the attendance section.
Yes, sir.
Okay. Okay. You are the student of CSC, and this is actually the time of springtime, and this is the physics 101 section A. If I want to add, this is the time slot of regular class, like 10 to 10:55, right? Okay, let's wait. This is not my class, so I have to check. This is the original price of which time? Okay, this is 8, 9. Okay, this is 10 to 10:55. Okay. Okay, 2019 batch 86. 2019 batch roll number 086 absent. Okay. 2020 batch roll number 029.
Present, sir.
Roll number 29.
Present, sir.
Okay. Then roll number 2. Please mute your microphone, whoever speaking in the background. This is very annoying for me. Okay, roll number 2. Absent. 4.
Yes, sir.
6. Absent. যাদের attendance হয়ে যাবে, they can leave now. Okay, roll number 8.
Present, sir.